Okay, up next we've got DP from Geofocus, or Deerpier, as everyone else says it.
They also say deeply, like you. A friend of mine is a business guy. He always tells me if you do a presentation, you have to leave people with a one-liner to take home. And he's quite good at it, so he always comes up with nice ones, like if the glove don't fit, you must acquit. So mine is that if you want to use GPR to map karstic features, so it's not as short as his, obviously, but one way to do that is to make the limestone really young and then to cover it in guano and then have somebody strip the guano off and then get your geophysical contractor in to come map it. And this is an example of where somebody went through all those steps and then got us in, and we were very able to map GPR. I'm less experienced than my age suggests, but I do have battle scars when it comes to GPR, as any contractor would have. But this is an example of where things went quite well. Okay, so where we went, this was in September 2023, and it's a survey we did in the Seychelles. So the Seychelles are split between the inner islands that are granitic, like Lou found out for us, and the outer islands, which are atolls. So how they form is you have a little volcano. If the hotspot moves off, the volcano will get washed away by normal wave action. If it's in tropical or subtropical environments, sometimes you'll have these atolls being built on this, right? So on the top of this, if this then is tall enough to be above the surface, you'll have a central lake with a ring and atoll around it. So this island, specific islands, the Assumption Island, you can see that there's only, there's only a little section of the atoll left. So why they got us involved is on this little island. You can imagine that this is, it's azure waters and it's, beautiful, a beautiful tropical island. So what they currently have a little runway on there, and the idea was to develop, redevelop that you can land proper aircraft on there, build a couple of villas, and some of the infrastructure you need to run a tourist operation from here. So that's what they got in. So what we wanted to do then is we wanted to say, okay, like we often do, is we want to map features that might be problematic, right? Cavities and depressions and the like. This is an idealized cross-section of the south of the island. And as you can see, all kinds of nice little, nice karstic features, which that doesn't quite make a light.
Top one.
Top one. Nice features that we would be able to map. Okay, so now what I could have done, which might have been more sensible, is I could have just put on some music and showed you all these wonderful GPR results. So I'm going to talk you through them, and hopefully I can show you that in this one instance, things work quite well. Okay, so there's a lot of development planned. What we did, so we did GPR and resistivity. We did GPR not, there's nothing clever like Wesley spoke about yesterday. It's standard GPR equipment from the shelf and standard GPR processing from the shelf. We started out doing a survey, which we would call an orientation survey, where we could see some of these features. This area's fill thickness is highly variable due to rugged limestone surface beneath, and there's the presence of possible infill dough lines, which are large depressions that have been filled in. And it's characterized by high, by a high frequency of quite small voids. See, that's some of the interpretation that we did just on the resistivity. Look at that. I mean, that's what we're selling, is beautiful GPR results. You get it every time you go near a karstic environment, but we did get it this one time. Okay. So the airline, the next part of the survey was to survey on the existing airway, on the existing airstrip. This turned out to be quite problematic. The central, it's quite complex. There's a high concentration of large depressions, rubble-filled cavities, and carrion relief beneath the sandfall. So it's quite susceptible to subsidence, sorry. And this is now, if you can imagine Ode to Joy playing, just how exactly these GPR and resistivity results just mimic each other, like textbooks. But this was not from a textbook. This was from Geofocus. Okay, so those are the findings. I think what then, to extend the airline, the idea was that it should go on into the northwest and to the southeast. In the northwest, there were a large number of cavities, that you could see on surface and that showed up in the GPR data, which is obviously huge, considers, it needs to be considered when you build. And the southeast, this predates my time as Geofocus a little bit, but the southeast, I think the report said there's probably not much to see, but this is GPR being GPR, and the water was just saline. So I would, there's probably some to see. This saline water table was just a bit high. But again, on the extension, as you can see, some, this wonderful correlation between resistivity and GPR. Okay. The next part was on the western, if you remember on the western, like little, in a bit of the kidney of the remaining atoll. This was, it's a different part of the geological section, and you didn't quite have the same problems, right? But yeah, there's two distinct geological conditions here, right? The footprints often straddle a raised limestone cliff and the beach sands, creating contrast in ground conditions that will require different foundation design strategies. And that is the Villiers, the observatory, and the far northeast. Again, the good correlation we saw before. And where we ended up with our survey is those would be, we've identified them, and I hope I've showed that some of the mapping of these karst features. The conclusions and recommendations are summarized here. I don't know if I actually want to say much more than show you that slide. Would that be appropriate? Is that good? Thank you.
Thanks, DP. Is it possible to go back the previous slide, just the Villiers, forward? No, that one. I missed to look at it quickly. Okay.
Would you like me to put them on top of each other?
Yes. Was it not as convincing to you? That's why you didn't overlay them.
You're not supposed to show off my dishonesty.
Okay, just checking. Any questions from the audience? Oh.
DP, what kind of instrumentation were you using?
I sometimes mix up the names, but we have a sub-echo, which it's like one of those long, looks like a ski sled.
Yeah.
It's got a central frequency of 40 megahertz. And we've got our equipment's changed a little bit since then, but we have I think it's called the dual, there's one's called the sub-echo, 20 meters, 40 megahertz, and the other one's got a dual frequency, I think 300 and 700 megahertz. Which we also used here. I don't think I showed any of those results.
Okay. And the range of resistivities over the various sites?
Oh, that's very good. I should have maybe checked that before I came to you, right? But I think everything was below 1,000 ohm meters. I will honestly email you the answer to that, but I don't think I see. You see up here it goes down to about 700 on the little resistivity inf picture, but I think it wasn't.
Being radar, what is the lowest resistivity you have there?
Sorry?
You're using a low frequency system which has got the best penetration depth, but that depth can still be constrained by lower resistivities of the formations.
Yeah.
So that brilliant section you showed where there was kind of a synclinal structure.
Which one?
Yeah. Any idea what the resistivity of the top material was?
No, but I'll email it to you if you want. If it's just for that, I will send it off to you.
Thank you.